This is my 1/33rd scale model of Dorney Park's Demon Drop Freefall Tower. Demon Drop is a first generation intimate drop tower that was first built in 1983 at Cedar Point and was there until 2009. From 2010 onward, it's been at Dorney Park. I've been working on this model since late July 2024 and I finished it at the beginning of June 2025, so it was about 10 months. It's not perfect, but it would never be done if I was trying to make it perfect. There are some things I would change, and I'll tell you about those. But for the sake of this project, I'm done, and I'm excited to show it off. 90% of the model is 3D printed. Most was done on my Prusa Mark IVs, and a couple parts were printed on a Prusa XL. All the track, structural parts, mechanics, and the base parts were printed from PETG. The cabins are printed from multicolor PLA. The SolidWorks assembly contains a little over 400 parts, but in reality there's probably closer to 450 3D printed parts. If I was to include fasteners in there, there's well around 1,000 pieces in the model. All told, I went through about 11 kilograms of PETG to print this. The design took about 2 months to complete, including a handful of redesigns. Assembly took another 4 months, and then everything else was just wiring and programming. The first generation Intamin drop tower was designed and manufactured by Giovanola. Intamin sold them, which is why most people call them first generation Intamin drop towers. Another name I've seen for them is the Freefall Tower. These are kind of hybrid roller coaster / drop tower rides. They're really popular back in the 80s, but they started to die out by the early to mid 2000s. They're pretty complicated, and from my understanding, they're no longer supported by Intamin and Giovanola no longer exists. That means getting replacement parts and service is going to be harder and more expensive. So that leads us to today. Nearly every freefall tower has closed and been scrapped. There are 5 left in the world, 3 of which being in Japan, 1 in Italy, and then 1 in the United States. Dorney Park is absolutely the perfect place for it. They've got a great collection of classic rides and Demon Drop fits right in. I first rode it when it was at Cedar Point. I'm a child of the late 2000s, so it was only there for the first couple years I remember visiting the park. I remember it towering over the entrance of the park and terrifying my younger self. But eventually my dad convinced my younger sister and I to get on it. I decided to build a model of it mostly because I thought it would be easy. I remember trying to build one as a kid out of Connects and it didn't work out super well. But at the time, I was also busy planning my wedding with my soon-to-be wife, so I wanted an easier project. The model behaves nearly identically to the actual ride. Each vehicle navigates through 5 sections of the ride, traveling through trapdoors to change the position of being upright or having the riders on their back. I made a handful of videos explaining the construction and how some of the mechanisms work. Check out the playlist I've created if you want to see more about that. My model can run up to 4 vehicles automatically, but in reality it runs 2, sometimes 3 the best. I usually run it with 2. The motions of going up the tower, transferring forward, dropping, and the uprighting behave nearly identical to the real ride. There are some minor differences to make the model easier to print. Most of the changes come down to how the cabin wheels are a little bit different from the actual ride, but for the most part it all behaves the same. The entire model runs off one Arduino Mega. And here it is. These are the controls for the model. It's messy, and I fully understand that. I'm not an electrician. I am not an electrical engineer, so this is a little out of my comfort zone. But essentially, all that's going on here is we have a Arduino Mega, which is under this little hat here with all the connectors on it. It's an Arduino Mega that is running a block system, kind of like a roller coaster. So only one vehicle can be in a block at a time, exactly like a coaster, and it spaces the cabins out such that when the block ahead is clear, it moves the next one up, and it does that all automatically. At the same time, it is also running the controls for the lift tower, the transfer, so like the push the cabins off the tower into the drop, and then it's also doing the dropping and upright control. So it's doing all that at the same time. Sounds complicated, but it's really not. It's just a lot of like if this then that. Pretty straightforward. Like I said, I am not an electrical engineer. I'm not a computer science guy. I don't program. I'm a mechanical engineer who just kind of figured this all out on his own. So I might not be using the proper terms for things, but feel free to roast me in the comments. But yeah, all you're seeing here is essentially just ways to turn on and off motors and take input from the actual model. So this board here, this green board, is actually a custom PCB that is essentially just a connector breakout board for a little multiplex chip right here. Essentially what's going on is all the Hall effect sensors are analog input, and there's only a number of analog inputs on the Arduino. So I'm using one analog input that goes to this chip that then splits it out into 8, and each cycle, each clock cycle of the Arduino, it quickly cycles through and takes input from all 8. I'm condensing 8 inputs down to 1. Then it's just looking at that analog value, and it triggers the program if it goes past a certain threshold. It's all fairly straightforward. All this PCB does is it just breaks out the pinout from this, as well as takes some motor inputs, and so each wire here goes to one motor Hall effect combo. And then underneath this board, you can't see because it's fastened down, but are just some MOSFETs or transistors that just turn on and off motors. So basically all this is just ways of turning on and off motors and feeling for input. It's not very complicated. It's just really messy. But now I know PCB design and manufacturing is not that scary. I would like to come back. This is one of the things I'd like to do. I'd like to come back and condense this all into one PCB. It's not going to happen for a little while just because I'm really done with this project. But it is something that I would like to do at some point in the future. And because it works just like a roller coaster would, it's something I could reuse for a Connect coaster project in the future. So yeah. And then the other things here, we have some buck converters. So it takes 12 volts in and then steps it down to various voltages for various different parts of the model. Pretty straightforward there. And then we have our reset button. So if you see the stray button, it's just a hardwired reset button because I can't get to the reset on the actual Arduino anymore because it's covered. So yep, pretty straightforward. So I've set up this little demo to show off the motor Hall effect combo and explain the blocking system a little bit. Like I said, it runs a block system very much like a roller coaster does. And the way I originally intended this to work was each motor Hall effect sensor. So the motors are these yellow plastic pieces, and the Hall effects are these little black pieces off to the side. The way I intended for it to originally run was each one was considered its own block, but I found that that was just a little too close to the magnets because I'm using a magnetic braking system. The magnets on the back of the cabins, if they got too close, sometimes they would attract to the steel wheels of the cabins and connect, and that was not very fun. So I ended up splitting the 8 motor Hall effect combos into 4 pairs of 2. So now the way it runs is there is one set is used to occupy or clear the block. So for instance, these 2 here are considered a block. This one here in the very front of the block occupies, when this sensor is triggered, it occupies this block, and then it also clears the block behind it. And then this sensor here, if it sees the one ahead is occupied, so this one would be over here. If it sees that block is occupied and another cabin, I'll try to move it in. I'm not running it right now just because it's really loud, but if I push this one in, it sees that one ahead is occupied and it'll stop. So this one will actually be in the tower. So pretend that's in the tower going up. Then once that one in the tower is about a third of the way up, it will move this into the tower into its park position where that cabin is at. And once the catch car for the tower parks, it will then roll that cabin onto the tower track and start the lift motor. So it's pretty straightforward. But like I said, it runs very similar to how an actual roller coaster would work. I've done a Arduino blocking system before on my very first project on this channel. If I was to condense all those electronics I just showed you to one single PCB, that's something I could absolutely reuse. I said there was a couple things I wanted to redo if I was to do this again. The condensing all those electronics to PCB is the first thing. The next thing I would redo are the magnetic brakes. So when I designed and built these brakes, originally I was using a cabin that was all one solid color, which was light and worked really well. I released a video that showed it working. It worked really well and I was happy with it. However, that was not the finished cabin. The finished cabins are these 3D printed, multicolored 3D printed cabins. I have one for Dorney Park and one for Cedar Point. The Dorney Park logo here is a little crooked because it's just double-sided tape, but these are multicolor prints. So essentially what happens is they're all PLA. The printer will stop mid-print, pull one color out, put another in, and then continue printing each layer. And that process works fairly well. I'm using the Prusa MMU system, and it works really well. But it doesn't matter whose system it is. There's a couple in the 3D printing world, like the Bamboo AMS or the Creality CFS. Doesn't matter who makes it. That process, so long as it's a single nozzle, can be quite wasteful. And this teal here on the Dorney Park style is kind of expensive. It's about double the price of regular PLA, so I really didn't want to reprint these cabins. The reason they're heavier is not because they're multicolor, but because the printer, when it's printing these colors, it prints, I'll show you a picture of it, internal interlocking geometry, because even though it's all the same plastic, there are some variations between manufacturers, so sometimes they don't fuse properly. On the Cedar Point ones here, this angled section here, it's too thin for that interlocking geometry. So I have a couple of these cabins that have that angled section broken off, and that's really annoying. So it's only on the Cedar Point ones. It doesn't seem to be an issue on the Dorney Park ones, even though there's actually 3 colors. There's a black on the inside, that teal, and then the gray. So that interlocking geometry adds extra mass to the cabins that these brakes weren't designed for. So they still work. It just so happens, though, that once it gets to the end of the run out, it still has too much speed. So I tried a couple things to slow them down. The first thing I tried was super simple. I put copper foil tape. So this is actually an aluminum bar. I put copper foil tape on to see if that would, it was more or less just an experiment more than anything else. I didn't think it was going to work because you want a thicker material for that, and this copper foil is too thin. And like I figured, it was too thin. But now I know that's the case. I won't try this again. But it looks kind of nice against the teal and the black. So I left it on. Plus I'm too lazy to clean it off. So the copper foil didn't work. So the other thing I did was, if you'll notice, these bottom bearings don't have a shield on. That's because when I buy them, I take the shields out and then degrease them. But the top bearings have those rubber shields on. So the top bearings are stock. They have the grease in them, which means they roll a little slower than the actual bottom bearings do. So that helps. If I was to do this again, I would either reprint these so that they have more magnets, which I don't have a ton of space, but it's something I could do. But like I said, this teal PLA only comes in a 500 gram spool. It's kind of wasteful to print these because I have to do the whole purge block thing. And it's, like I said, twice the price. So I really don't want to reprint these unless I absolutely had to. I was able to slow them down with the bearing, but I think what I would do in the future is just get a copper bar. They sell them online, not terribly expensive, and it's something I could reuse for other projects. But that's neither here nor there. I was able to get them to slow down enough, so it's fine now. The upright mechanism here worked out really well. I didn't actually end up using these trapdoors like I thought it would. I found that it actually works just a little better coasting over that gap. This wasn't great, but the bearings running over that gap helps sap up just a little bit more momentum. Probably not great for the track, but it's a fairly easy part to replace if it breaks. So, you know, not the greatest way to run things, but it is what it is, I suppose. But the actual uprighting mechanism works super well. Like I said, it's a little bit different than the actual ride because of these bearings. Because the bearing setup is a little bit different than the actual ride. But I'm pleased with it. There's no changes I've really made to it. That was my biggest unknown, was just how was this going to work, but it works really well. No changes there. The last thing that I want to talk specifically about are the finished cabins. I talked about them a little bit beforehand, but we'll talk a little bit more about them now. The cabins. I have two styles I've printed. So when the transition from Cedar Point to Dorney Park, the physical ride did not change in aesthetics or anything like that. I don't even know if they painted the ride, but the cabins got a repaint. So I have two styles. I have the classic retro Cedar Point 1980s with the Cedar Point logo, and then I have the modern ish Dorney Park style. Um, I'm really happy with the way these turned out. Other than they're a little too heavy, but they look great. They operate super well. I especially love this. It's hard to pick up on the camera, but this TLPLA, like I said, it was really expensive in comparison, but it is a really gorgeous plastic. So I have some spare. I have some leftover of this that I don't know what I'm going to do with it, but it's too nice to just waste on like benchies or other 3D printed tchotchkes. So I don't know what I'm going to do, but it looks really nice, and I'm really happy with the way they turned out. Other than the Cedar Point one here is a little fragile, but that's okay. I have some spares. This one is just off the shelf PLA, super easy. Uh, is super cheap, so I'm not super worried about reprinting those. So I think they turned out really well, and I'm very happy with them. So that's the Model Demon Drop project. It is 10 months in the making, but it's super satisfying to have this thing done. From here on out, I'm not entirely sure what I'm going to do with it. At some point, we're going to move, and it will be coming with us because I spent too much time and too much money to just throw it in the trash. But for now, it's just taking up the corner of my apartment, looking really cool, and that is worth something, I think. But at some point, like I said, it's going to need to move. That's probably the time I may or may not tackle that stuff. I did design it to come apart into two pieces, so it will make transporting a little easier. But for now, this is it. That's the end of this project. So next project will be Connects focused. I am still kind of working out what I want it to be. But if you guys have any suggestions, go ahead and leave it in the comments. Last summer, I started working on a pneumatic launch coaster. I could get back into that. Or I have a couple other things I might be able to do, like a transfer table, like a high-speed transfer switch or something like that. So if you guys have any suggestions or any desires of things you want to see, go ahead and leave it in the comments below. Otherwise, thank you guys very much for your support, and thank you for watching.